Today we are going to continue with revision of the main points about Lesson 2 Unit 1 and Lesson 1 on Unit 2. We previously revised the main point on the first lesson of the Unit 1, Chemical Reactions. Today we are going to carry on with the second lesson of Unit 1, Speed of Chemical Reactions. The speed of chemical reactions is the change in the concentration of the reactants and the resultants at a unit time. The factors which affect the speed of chemical reactions are the nature of the reactants, the concentration of the reactants, the temperature of reaction, and the catalysts. Catalysts. They change the speed of reactions, but they don't affect either its beginning or stopping. They are used in a very few amounts. They are bonded to the reactants during the reaction, but get separated from them quickly at the end of the reaction. They decrease the energy needed for the reaction, and no chemical changes or decrease in mass occurs to the catalyst after ending the reactions. Enzymes are those chemical substances which are produced by human bodies which act as catalysts to increase the speed of biological reactions. And these were all the main points for the second lesson of Unit 1. Let's carry on with Unit 2. First lesson. Physical properties of the electric current. Before learning the properties of the electric current, we need to understand what electric current is. We have studied previously that all elements consist of atoms, which consist of electrons and the nucleus. Electrons are the negatively charged particles and the nucleus is positively charged. There is an attraction force between electrons, which are negatively charged, and the nucleus positively charged. When this attraction force is weak, electrons will leave the atom and become free. As you see here, this electron becomes free because the attraction force is weak. So, the flow of electric negative charges, electrons, through a conducting material is what we call electric current. So here you can see the flow of electrons. Okay. Current intensity. Current intensity is the quantity of electricity in coulomb or the electric charges flowing through a cross-section of the conductor in 1 second. So as you might see here, the flow of the electrons or the negative charges through this cross-section in 1 second is going to give what we call electric current intensity. But to have electric current intensity, we need a full circuit. We need wires, we need the lamp, and then we need battery. As you might see here, when the circuit is closed, the electrons are going to flow through the wires and through all this electric circuit. In the other side, we have another electric circuit, but open. When the electric circuit is open, the electrons are not able to flow through the electric circuit. So there is no light on, as you might see. So current intensity is equal to the quantity of charge, which we write it as Q, over time in seconds, S. Current intensity is the quantity of electricity in coulomb or the electric charges flowing through a cross-section of the conductor in 1 second. Is equal quantity of charge over time in seconds. 1 ampere is equal 1 coulomb over 1 second. The ampere itself is the electric current intensity passing through a circuit when a quantity of charge of 1 coulomb passes through a given cross-section in 1 second. The coulomb itself is the quantity of charge transferred by a constant current intensity of 1 ampere in 1 second. Current intensity is going to be measured with a meter. A meter is connected in series in the electric circuit. As you might see here in this electric circuit, is connected into series. Okay. So, we said that to have electric current we need to have free electrons, but it's not enough just having free electrons. As you might see in this copper wire, we have free electrons, but they are not flowing through the copper wire. They are just moving around, because there is nothing to push them to flow through. But after we connect the battery in the electric circuit, as you might see, the electrons are going to flow through the electric circuit. This one is because in the battery there is electric potential difference. Electric potential difference means that there is a difference between the two terminals, so the electrons are going to pass from the high potential to the low potential. Electric potential is the state of an electric conductor that shows the transfer of electricity from or to it when it is connected to another conductor. Potential difference, it is the value of the work done to transfer a quantity of charge of 1 coulomb between the two poles of this conductor. Potential difference, V, is equal work over amount of charge. 1 volt is equal 1 joule over 1 coulomb. Joule is the unit for the work and coulomb is the unit for the amount of charge, while for potential difference the unit is volt. The volt is the potential difference across two terminals of a conductor on doing a work of 1 joule to transfer a quantity of charge of 1 coulomb. The electromotive force, it is the potential difference between the two poles of the battery when the electric circuit is open, so no current passes through the circuit. So as you might see, the batteries, they have some values, maybe 1.5 volt or 3 volts. These numbers which you see in the battery before putting the battery in the electric circuit, this is what we are going to call the potential difference between the two poles of the battery. These values which are written over the batteries. Potential difference and the electromotive force are going to be measured by a voltmeter, and voltmeter is set up on the electric circuit in a parallel. Let's carry on with the last physical property of the electric current. Electric resistance. If an electric current flows through a conductor, the free electrons move between the atoms of the atomic lattice. Here are the atoms, and then these are the electrons which move through between them. In this process, collisions occur, deflecting the free electrons and retarding their motion. As you might see here, there is a collision between the electrons and the atoms of the lattice. The conductor thus exerts a resistance on the electric current that must be overcome by the voltage. So the electric resistance, it is the opposition that the electric current faces during its passing through a conductor. There are few factors which affect electric resistance: the cross-sectional area of the conductor, the length of the conductor, the material of the conductor, and the temperature of the conductor. So each material has its own electric resistance. Electric resistance is two types: the constant fixed resistance and the variable resistance or sliding rheostat. As we previously said, the electric resistance is directly proportional to the length of the conductor. So by sliding the slider in the rheostat, we can change the resistance, and so we can control the electric current intensity flowing through the circuit and the potential difference in the different parts of the circuit. As you might see here from the video, when the length of the conductor increases, the resistance will increase and the intensity which is provided in the terminal B is going to get decreased. If you pay attention to the video, as the length of the conductor is increased, here this arrow is going to be thinner, which means there is less intensity. And the apparatus to measure the electric resistance is called ohmmeter. The unit for the electric resistance is ohm. The relation between the current intensity and the potential difference, they are related to what we call Ohm's law. The electric current intensity passing through a conductor is directly proportional to the potential difference across it at constant temperature. So Ohm's law says that the resistance is directly proportional to the potential difference, but inversely proportional to the electric current intensity. And these were all the main points for the first lesson of Unit 2 and the second lesson of Unit 1, which we said earlier. Thank you for watching.